Here we want to find this double integral using polar coordinate system. Notice that y ranges from negative square root of 4x minus x squared to the square root of 4x minus x squared. And then x is between 0 and 4. This is the graph for y equal to the square root of 4x minus x squared. This is the graph for y equal to negative square root of 4x minus x squared. And so this is region R. And so notice that region R is in the fourth quadrant. This is in the fourth quadrant and in the first quadrant. X ranges from 0 to 4. The relationship between the rectangular system and the polar coordinate system is r squared equal to x squared plus y squared. X is equal to r cosine of theta. Y is equal to r sine of theta. This is the double integral in the rectangular system. The corresponding double integral in the polar coordinate system is this. Here we have y is equal to the square root of 4x minus x squared. We want to rewrite this equation in the polar coordinate as we want to find the corresponding equation in the polar coordinate system. Square both sides, we get y squared is equal to 4x minus x squared. Add x squared to both sides, we get x squared plus y squared is equal to 4x. R squared, x squared plus y squared is r squared. X is r cosine of theta. And so we get r squared is equal to 4r cosine of theta. Divide both sides by r, we get r is 4 cosine of theta. This is region R, and region R lies in the fourth quadrant and the first quadrant. This is the double integral in the rectangular system. Since region R is in the fourth quadrant and the first quadrant, theta ranges from negative pi over 2 to pi. So we're going from here, up to here. So this is negative pi over 2 to 0, and then 0 to pi over 2. The radius ranges from 0 to 4 cosine of theta. The radius will go from 0 to 4 cosine of theta. x squared plus y squared is equal to r squared. And then we have more dr d theta. This is r to the third. R squared times r is r to the third. Now let's evaluate the inside integral. The antiderivative will be r to the fourth dividing by 4. R ranges from 0 to 4 cosine of theta. So we get 4 cosine of theta to the fourth dividing by 4. 4 to the fourth is 256 dividing by 4 is 64. And we get cosine to the fourth of theta. And when r is 0, we just have 0. So the inside integral is 64 cosine to the fourth of theta. And so the inside integral here is 64 cosine to the fourth of theta. In an earlier video, we have shown that the integral of cosine to the fourth is 3/8 theta plus 1/4 sine of 2 theta plus 1 over 16 sine of 2 theta cosine of 2 theta. For this video, see the description section for the video link. And so we have 64 times all of this, and now evaluate from negative pi over 2 to pi over 2. When theta is pi over 2 here, we get 3 pi over 16. For theta equal to pi over 2, 2 times pi over 2 is pi. Sine of pi is 0. And same here, sine of pi is 0. When theta is negative pi over 2, then we get negative 3 pi over 16. And right here, when theta is negative pi over 2, 2 times negative pi over 2 is negative pi. Sine of negative pi is 0, and then 0. So we end up with 24 pi. This is the answer.